Hello everybody, this is Coach Knight again. Today's lesson we're going to talk about simplifying and verifying trig expressions and trig identities. So trig identities, you simplify using trig identities, you simplify the expressions. For verifying trig identities, basically you're going to have something that says it's equal, and verify basically is just a fancy word for prove. You're going to have to prove that they're equal. So we're going to take these one at a time. First, we're going to simplify trig expressions. Now, to do that, you can see over here to the left, we have some trig identities. There are more than these. These are just the ones that we're using today. Depending on what class you're in or what book you're using, you might have more identities than this or less identities than this. And there are many more, but these are the ones that we're going to be using. And you can see they're on the left side. It's not different ones. They're the same ones. I put them everywhere, so as I scrolled, I could see them very easily. The more familiar you are with the identities, the easier these problems are, okay? So very, very important, especially for the ACT. If you know your identities, a lot of the problems are really, really easy. If you don't, you can still do the problem, but it just takes a lot longer to do them. So here we go. Basically, what you're going to do is you're going to simplify the expression they've given you. So on number one, they've said the tangent of pi over 2 minus theta times sine of theta. Now, there are a few instructions, suggestions, however you want to say it as to how to work these problems. And one of the problems, one of these suggestions is to change everything into sine and cosine. That's one of them. Another one is to look at what you're given. Like, for example, in number one, we're giving tangent of pi over 2 minus theta. Well, if you look over here to the left, you'll see the cofunction identities. You'll see that tangent of pi over 2 minus theta equals the cotangent of theta. So that's simpler. So we're going to change that to cotangent of theta. Make that a little bigger. Okay? Notice I haven't messed with sine. Sine's just going to stay sine of theta. Okay? Now we're going to use the other suggestion I made, which is to try to make everything into sine and cosine. Well, again, we're going to take this cotangent. It's not sine or cosine, so I'll come over here to the tangent and cotangent identities, and I can see that cotangent is equal to cosine over sine. So again, I change cotangent theta to cosine theta over sine of theta times the sine of theta, and now you can see what's happening with the math. When you multiply those, the sines cancel, and you're just left with cosine of theta. And that's all you're doing on these problems. You're just simplifying them to a little simpler expression, okay? Usually you can get it down to one trig function or maybe two trig functions adding together or something like that. It's very, very simple. All right, I'm going to erase what we've done over here to the left because we're going to highlight some more. Number two, secant theta times tangent squared theta plus secant theta. Well, there's a couple ways to do this. We can change everything to sine and cosine. That's one way. Or you can actually factor here. I am going to actually go the factor route because every time I see a square, I'm going to think Pythagorean identities, because as you can see, all the Pythagorean identities have squares in them, okay? So I'm going to factor out what they have in common. So they have in common a secant of theta. So I'm going to bring that secant theta out front, and when I do that, that will leave me with tangent squared theta plus 1. All I did was factor, okay? If I distributed the secant back into it, it would look exactly like it did before, okay? But I'm not going to do that because that would defeat the purpose. All right, now I can take this tangent squared theta plus 1, and if you look right here, tangent squared theta plus 1 or 1 plus tangent squared theta, it's the same thing. That equals to secant squared theta. And then you have secant squared theta times secant is secant cubed theta. And that's about as simple as it gets. Okay. Moving on, number 3. Again, same thing we're doing here. We're just figuring out how to simplify. Okay. So notice sine x, cotangent x, secant x. There's no squares, there's no negatives, there's no minus thetas, there's nothing like that. It's just good old sine, cosine, or cotangent and secant. So this is a perfect example of a problem we're going to work where we're going to change everything to sine and cosine. So the sine x is not going to change. It's going to stay sine x. Cotangent x, we've already talked about it. We can change that to cosine over sine. So cosine x over sine x. And then for secant x, we can change it up here for the reciprocal identities. Secant is equal to 1 over cosine. So I'm going to change that to 1 over cosine x. And now that we have everything into sine and cosine, things cancel. The sines cancel, the cosines cancel, and we're left with 1. That is as simple as it gets right there. Okay. Number 4, again, we're going to see if we can't change everything to sine and cosine. Well, the great thing about number 4 is it's already sine and cosine. So we don't need to worry about that. They're already in sine and cosine. We're going to work number 4 kind of like we worked number 2, because as you can see, there's a cosine theta in both parts. So what we're going to do is we are going to factor that cosine theta out, and it will be left with 1 minus sine squared theta equals 0, or equals, I don't know what it equals, excuse me. So we're simplifying. So from here, remember I told you every time you see a square, you need to think Pythagorean identities. Now it doesn't mean you're going to use it, but most of the time you do. Now if you'll notice, there is not a perfect 1 minus sine squared theta on the Pythagorean identities. However, if we took this one right here, this first one, and we moved sine squared theta over, okay, those will cancel, and now you'll see that cosine squared equals 1 minus sine squared. So this will be cosine theta times cosine squared theta, which is cosine cubed theta. And again, just simplifying. Number 5, again, we don't have anything special, no squares, no adding or subtracting, no doing negatives. So the best way to do this one is to just change everything into sine and cosine. So tangent, I can change to sine and cosine by saying, hey, that's sine over cosine. So change that to sine x over cosine x. Cosecant. Cosecant is right here. It becomes 1 over sine x divided by secant x is right there, and you can see that it is 1 over cosine x. Now notice, in the identities, our variable is theta, and in the problem, it's x. Understand, that doesn't matter, okay? They're just variables, okay? You can let the variable be whatever you want it to be. Let's simplify this. That would be, let's see here on top, the sines cancel. So we're left with 1 over cosine x divided by 1 over cosine x. And when you divide something by itself, you get 1. So that's 5 examples of how to simplify trig expressions. Now we're going to do 4 or 5 examples of how to verify trig identities. So this is an identity, number 1 here. It's an identity. The rule to verify trig identities is you cannot take something from one side and move it over to the other side. You have to work each side individually, okay? Most of the time it's better to work the more complicated side, Sometimes they're about the same in complexity. So you just have to start somewhere and hopefully it works. Number one here, if you will remember our suggestion, change everything to sine and cosine. I don't see any squares or anything, but I can change secant to 1 over cosine, and I can change tangent to sine over cosine. So I'm going to do that first. So this is 1 over cosine x plus sine x over cosine x. Okay, and I found those right there and right there. Those are the two identities I just used. Since the denominator has cosine x for both of them, I can write that as one fraction, 1 plus sine of x over cosine of x. And I'm almost done. The problem is I got 1 plus sine x over cosine x, and over here, that's backwards. The cosine of x is on top, and I have 1 minus sine x on the bottom. So I'm going to have to do a little rearranging here somehow. It doesn't matter which way you do it. You can change the left side or the right side. I'm going to change the right side, okay? I've worked with the left. I've got it to here. I want the left side to look like the right side. So if you'll notice on the left, I have 1 plus sine of x. So over here, I'm going to put 1 plus sine of x on top. But if I put it on top, I also have to put it on the bottom because I can't change the value of it, okay? So basically, it's like multiplying this whole thing by 1. I multiplied it by something over itself, which is 1, okay? So on top, we will now have cosine x times 1 plus sine x. And if you FOIL the bottom, these are conjugates of each other. And so you will get 1 minus sine squared x. And we've already talked about 1 minus sine squared x is cosine squared x. So that will end up being cosine of x times 1 plus sine x divided by cosine squared x. And when you have a cosine x on top and a cosine squared x on bottom, they cancel. And you're left with just a cosine x on the bottom. So 1 plus sine x over cosine x, which is the exact same thing as we got on the left side. As soon as you get the same thing on both sides, you're finished. You have verified it, okay? Number 2 is not near as long. Here's one where it's pretty simple. We have a cotangent of negative theta. So if you look at your negative angle identities, it says, oops, I touched the wrong one. It says the cotangent of negative theta. I'm going to change everything to sine and cosine, and you'll see why in a second. I'm going to use that. I'm going to say, hey, if cotangent of theta is cosine over sine theta, then cotangent of negative theta would be cosine of negative theta over sine of negative theta. Okay, the negatives just stay. And now we can use our negative identities here. Okay, so it says cosine of negative theta equals positive cosine of theta, and sine of negative theta equals negative sine of theta. Okay, so I used this one for the cosine of negative theta, and I used this one for the sine of negative theta. Okay, so now we can go right back up here to the cotangent identities. This is negative cotangent theta. Got the same thing, we're done. As soon as you get the same thing on one side as you do on the other, you are finished. So that's what we were looking for. All right, number 3. We have squares. So remember, what do I say when you see a square? You want to think Pythagorean identities, okay? So right here, this first one, 1 minus sine squared is cosine squared. So we're going to have cosecant squared x times cosine squared x equals, And again, notice I'm working the left side because it's a little more complicated than the right side. Then I'm going to change my cosecant squared x to 1 over sine x, because remember, that's another suggestion. Try to change everything to sine and cosine. So this would be 1 over sine squared x times cosine squared x, and that will equal cosine squared x over sine squared x, and that reduces to cotangent squared x. Again, as soon as you get the same thing on both sides, you have verified it. Number 4, again, very simple to know which one's more complicated on this one. The left side's more complicated, so I'm going to change everything into sine and cosine. So the cosine x stays. I'm going to change that cosecant x to 1 over sine x. And I'm going to change that tangent x to sine x over cosine x. And again, if you don't know where I'm getting all this, I'm getting them from my identities. You just have to be familiar enough with them. Memorizing them is the best case, but at least be familiar enough with them to use them while you're looking at it. So when you do this, the sines cancel, the cosines cancel. You're left with 1, which is what's on the right side. So we're done. And finally, our last one, number 5. Uh-oh, I see squares. So when you see squares, think Pythagorean identities. So tangent squared x plus 1. Tangent squared x plus 1 is secant squared x. So this is, I'm going to change this to secant squared x. Cosine squared x minus 1. This one I'm going to use here. If cosine squared x minus 1, well, cosine squared minus 1 would actually be, if I move this 1 over, let me do a little side problem over here. I'm going to show you what I'm doing. All right, so I know I got the 1 and I got the cosine squared. I'm trying to use this, so I'm going to rewrite it a little bigger over here. Sine squared theta plus cosine squared theta equals 1. So if I move the 1 over, now I will have sine squared theta plus cosine squared theta minus 1 equals 0. And if I move my sine squared over, now I can see that cosine squared theta minus 1 equals negative sine squared theta. So I'm going to replace this cosine squared x minus 1 with negative sine squared x. And now I change the secant squared to 1 over cosine squared times negative sine squared x. That will equal negative sine squared x divided by negative cosine squared x, which is, not negative cosine squared x, positive cosine squared x, which would give me negative tangent squared x. As soon as I get the same thing on both sides, I'm done. So, hope this little video helps. Again, you just need to be very familiar with your identities. The more familiar you are with them and how to use them, the easier the problems will be. Hope y'all have a great day, and as always, stay above the line.